In this video, we're going to take a look at the properties of exponents. So we're familiar with exponents like 2 to the 4th. We kind of know what that means. 2 times 2 times 2 times 2. What if we throw some variables in there? We have x squared times x to the third. Can we rewrite these different ways? That's what we're going to look into. And the big question that we always want to ask ourselves when we're working with exponents is, what does that mean? And we got these properties that we'll go through, and you can memorize them, and you will memorize them, but more importantly is to understand what they mean, and you can always recreate them really easily. So let's look into some of these things. First thing we're going to look at is, what if we have a 0 or a negative exponent? So again, we're familiar with something like 2 to the 4th. Well, that means 2 times 2 times 2 times 2, which is 16. If we have 2 to the third, that's 2 times 2 times 2, that's 8. If we have 2 to the second, 2 times 2, that's 4. 2 to the first, okay, that's just a single 2. Well, then the question is, what is 2 to the 0? Well, if we look at the pattern here, what's happening as we go down? 16 becomes 8. Well, that's just dividing by 2, right? 8 to 4, that's half as much there. 4 to 2, that's half as much. So what has to come next? Well, following the pattern, we divide by 2, and 2 divided by 2 is 1. Well, that's kind of interesting. I wonder if that works with 3. 3 to the 4th, that's 3 times 3 times 3 times 3. Jot that down over here. And 3 times 3 is 9, times 3 is 27, times 3 is 81. 3 to the third is 27. 3 times 3 times 3, 3 squared. 3 times 3 is 9. 3 to the first is 3. And what's happening every time here? Well, 81 to 27, and then 21 7 is going to 9, and 9 is going down to 3. Well, we're dividing by 3 every time. 27 divided by 3 is 9. 9 divided by 3 is 3. So we see a pattern. So we say, well, what is 3 to the 0 going to be? Well, we're going to divide by 3 there. 3 divided by 3. So if we take 3 divided by 3, we're going to get 1. And we could do this with any base. Okay, so we find out that 2 to the 0 is just 1. 3 to the 0 is 1. And in general, if we have a to the 0 power, anything to the 0 power, that's going to be 1. Oh, what am I writing there? Sorry, did you catch that? Said it, but I think I wrote the wrong thing. 3 to the 0 is 1. A to the 0 is 1. Anything to the 0 power is 1. Okay, and again, we can kind of follow this logic here, and that makes sense. Well, what if we have 2 to the negative 1? Well, let's continue the pattern. Notice that our exponents here are going 4, 3, 2, 1, 0, negative 1. We're going down by 1 every time. Well, let's divide by 2. We have 1 divided by 2. Well, 1 divided by 2 is 1 over 2, 1/2. Huh. What about 2 to the negative 2? Let's keep it going. Well, if we divide this by 2, half of 1/2 divided by 2, 4th. Whoops. 1/2 divided by 2 is a 4th. And 4, which we noticed up here, 4 is just 2 to the second. So I'm going to write this a little differently. 1 over 2 to the second. And let's try that one more time. 1/4 divided by 2 is 1/8. So if we go down one more step, we got 1/8. And 8, if we look up above here, 8 is just 2 to the third. So this is just 1 over 2 to the third. So what happens here? When we have a negative exponent, that power gets dropped down to the bottom, and we have 2, or more specifically, 1 over 2 to the first. 2 to the negative second here drops down to the bottom and becomes 1 over 2 to the positive second. 2 to the negative third becomes 1 over 2 to the positive third. And the same kind of pattern is going to continue for 3 to the negative 1, and 3 to the negative 2, and 3 to the negative 3. Divide the 1 by 3 here, and we have 1/3, or 1 over 3 to the first. Divide this by 3, 1/3 divided by 3 is 1/9. Well, that's just 1 over 3 squared. And 3 to the negative third, we'll divide this by 3. 1/3 of 1/9, or 1/9 divided by 3 is 1/27. That's 1 over 3 to the third. So we see that 3 to the negative, let's go n power, is 1 over 3 to the n. 2 to the negative n power, same story, is 1 over 2 to the positive n power. Okay? And in general, if we have a to the negative n power, that's 1 over a to the positive n. All right, so there's our rule for negative exponents and zero exponents. Negatives become fractions, drop down the denominator. 0 power is just equal to 1. So now what if we have things like multiplying? Here we have 2 powers, and we're multiplying them. A to the third times a to the second. Well, here's where that big question comes in. What does this mean? Well, what does a to the third mean? A to the third means a times a times a. There's some multiplication going on in between here. A to the second means a times a. Well, we don't really need these parentheses there. I put them there to separate so we can see that there's 3 a's multiplied together here and 2 a's multiplied here. So let's just go ahead and get rid of those parentheses. A times a times a times a times a. Well, that's 5 a's all multiplied together. And how do we write that? It's a to the 5th power. Okay? So, what's going on here? A to the third times a to the second is just equal to a to the 5th. And where did that 5 come from? Well, we can see we had 3 plus 2 gives us a total of 5. So when we're multiplying powers with the same base, we're going to add the exponent. Remember, the exponent is this guy up top. That's the exponent. Okay? What if we have a quotient, or we're dividing? When we divide powers with the same base, we have the same base. The base is the a here. That is called the base number. Okay? Well, let's ask ourselves the big question. What does this mean? This is a times a times a times a all over a squared, which is a times a. Well, we could rearrange this a little bit. This is like a times a, and let's kind of put this under here. So I'm going to put those 2 a's over here. We rearrange. Remember, when we're multiplying fractions, we just multiply the top, multiply the bottom. So this is still a times a times a times a times a times 1, which is a times a. Same thing. We got the same stuff. But what is a over a here? Well, a over a, we know, is just 1, because they're the same. They cancel. A over a here is 1. And when you're multiplying by 1, it doesn't change anything. So these go away, and we're just left with a over a, or a times a, actually. A times a, which is a squared. So in the end, we get a squared. Well, what happened? We had 4 a's on top being multiplied, 2 a's on bottom being multiplied. 2 of these canceled out 2 of those, so 4 minus 2 gave us 2. So when we're dividing powers with the same base, we subtract the exponents. Okay? So if we have, it doesn't matter what we have, x to the 13th times x to the 7th. Well, that's going to be equal to x to the 13 plus 7, which is x to the 20th. So we can simplify it as the same base. One more dividing example here. What if we have x to the 13th divided by x to the 7th? Well, there we're going to subtract x to the 13 minus 7, because 7 of these will cancel out with 7 of these, kind of like this. You could write it out if you wanted to, but we don't need to. That's going to be x to the 5th. Okay? And a couple more situations here. What if we have a power to a power? If we have a power of a power. So a power, this whole thing in here is called a power. Has a base and an exponent. Those things together are called a power. So if we have a squared to the 3rd power, well, what does that mean? That means a squared times a squared times a squared. Well, this just means a times a times a times a times a times a, which we have a to the 6th. What happened to the exponents there? Well, here we had 3 groups of 2, and that's 6. So did they add? No, they multiplied. So 3 groups of 2 were multiplying the exponents. So to find a power to power, we're going to multiply the exponents, and that will give us our new expression. What if we have a product to a power, AB to the 3rd power? Well, that's AB times AB times AB. And these are all just multiplication, a times b times a times b times a times b. So we really have a times a times a times b times b times b. We're allowed to flip them around with commutative property. That's a to the 3rd times b to the 3rd. So this exponent really applied to both. So to find a power of a product, this is a product in here, we're going to find the product of the power of each. Okay, in other words, the power gets applied to each. It's not really distribution, but in a way you can kind of think of it like it is. What if we have the quotient, a power of a quotient? Quotient means divide. Well, this is a over b to the 3rd power, so times a over b times a over b. Well, on top we have a times a times a, that's just a to the 3rd. On the bottom we got b times b times b, that's just b to the 3rd. So we see that here the power affects both of these. So we divide the powers of the numerator and the denominator. So a to the 3rd power, b to the 3rd power, we divide it. So in other words, that exponent gets applied to both. All right, let's try a couple examples here. So now let's put it all together. Here we have some expressions, and we want to simplify them. So we're going to use our properties all along. And there's lots of ways to go here, several ways to go. Okay, here, let's start by applying this property that 3 applies to both of these. So we're going to have 2 to the 3rd, and we're going to have x squared to the 3rd. And here, we can do a couple things. We've got this x to the negative 1. What we might want to do first is we want to make that positive. So let's make this 3 over x to the positive 1 to the 4th power. Okay, well, here, let's keep going. We know this is 2 to the 3rd. We know 2 to the 3rd. That's 8. If you can figure something out, go ahead and figure out what it is exactly, because it's a number. X squared to the 3rd, well, that's x to the 6th. And here, this exponent 4, which one does it go on? It goes on both. So we're going to apply it to both. 3 to the 4th over x to the 4th. Okay? And so we got 8x to the 6th times 3 to the 4th. Well, we know what that is. I think I do. That's going to be 81 over x to the 4th. Now we've got to multiply these up, so let's go ahead and put this over 1. We got on top, we have 8 times 81. Well, 8 times 8 is 64. So I think this is 648. X to the 6 on top. On bottom, we just have 1 times x to the 4th. That's x to the 4th. And we're almost done here. We've got x to the 6 on top, x to the 4th on bottom. And what's the rule or the property when we have a power divided by a power? We subtract the exponents, right? 6 minus 4 is 2. So there is the simplified answer. So this whole thing simplifies to this using all of our properties. Go step by step, one at a time. Now we could have also just called this x to the negative 4th and added. That would have worked just fine as well. So there's more than one way to go. All right. How about this guy? We've got a cubed over b squared. Let's leave that alone. Nothing to do there. In fact, I'm just going to get rid of the parentheses. A cubed over b squared. We have b squared, b to the 5th over x to the 6th. And so it's going to be b to the 5th squared over a to the 6th squared. And we do power to power, we multiply. So let me rewrite over here. So that's times b to the 10th over a to the 12th. Okay. Putting them all together, we have a to the 3rd, a to the 12th. We have b to the 10th over b to the 3rd. Now, let's subtract the exponents. We have a to the 3 minus 12. Well, 3 minus 12 is negative 9. And we have b to the 10 minus 3, so that's going to be 7. Now, when we're simplifying, we don't want to leave negative exponents. So this is an equivalent expression. This is true that this simplifies to this part down here, but we don't want to leave negative exponents. So remember, when we have a to the negative 9th on top, that's going to go down to the bottom and become a to the positive 9th. So we have b to the 7th over a to the 9th, and that is our final answer. We don't want any negative exponents in our final answer. All right? And that's how we do it. So follow your rules, your properties, one step at a time. Write it out. Don't jump too far, and you'll get to the end just fine. Have fun, and good luck.